as part of the double linked list concept, and now we'll see insert at end and insert at a given position, how to insert the nodes in a double linked list. We'll continue the program.
Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus.
So once again I'm showing the program. So where we have done, so where we have taken a struct and we have taken head node and tail node, and we created we have done with the choices for the user. So 1 for creating a node, 2 for inserting at beginning, 3 for display, of course 4 for exit, and 5 for display in reverse. We have written case 1, 2, 3, 4, 5. According to that, each function we have defined like this: insert at beginning, display, display in reverse also. So we'll go to the next one, which is inserting at the end first of all. So the node I want to insert at end, how to make it we'll see. Case 6 I am writing. Of course node you want to insert, that's why I need the value. I'll copy this part. So I'll rename it as insert at end, which is insert underscore end. So with respect to the given value, we'll try to write the function. So void insert underscore end, the given value int x, and anyway we have to copy this one. We'll go for insert underscore begin. Where is a function here? Anyway, I need to create a new node, and till now it is fine. Why? Because if head is equals to null, that is also fine. Till this I'll copy first. Now that means here assume that these are the nodes exist. This is 100, let us suppose. So connected like this. So value is something like 10. Maybe here 250, the address means here 250. And anyway for the first node it is previous is null, and might be the value is 20 here. So if I connect like this, means previous address is 100 like this, and here let us suppose this is 350 like this. So if I connect like this, so this address is previous node is 250, let us suppose this is 30, and here what is the next node address? 350, and here it is null. Now I want to insert a node here, which is a node with the value 40. I want to insert, and here initially it is null, previous is also null. Now anyway this is a head node and this is a tail node, the last node, which is 30. Now for this, if I want to connect like this, what changes to be done here? That is what we have to know. Anyway, this is a new node nn. Now we created with respect to this nn of data equals to x, which is 40. In this example, nn of previous null, nn of next is also null. Now what changes you need to do here? When you connect, mean this part has to be tail of next. What is tail? We know this is the last node. Tail of next should be current. So that is the first thing you need to write. Tail of next is equals to the current node. Then it will be the address nn, so that it is connected. Now what is this nn of previous? What is nn of previous? Here it should be the previous node, which is tail node, which is the address is 350. So nn of previous is equals to what is a tail node, that you can write it. And one more thing you need to observe, here nn anyway it is connected, so here previous value fine, but what about tail? Anyway this is null, absolutely fine. Why? Because the last node next to is definitely null. Now what is a tail node now? Is it this one? No, the last node is this one. Tail has to be updated, so tail is equals to nn. So these three things you need to do. Of course we have taken the tail node, that's why there is no loop. We are writing with only complexity 1. There is no what you call as nested loop, that's why there is no n complexity. We are writing with constant complexity. So these three statements are very much needed here. You can see else. I'm writing here the logic whatever I explained just now. So what is that? First, tail of next. What is tail? We know tail of next is equals to the given node, current node, which you are inserting at the last. What is nn of previous? What is nn of previous? Should be the previous should be the tail node, whatever is it. Now once it is done, tail has to be updated, where tail is equals to nn. Current node will be the last node. That's it. I think the answer is over. We'll see the output. Yeah, this is what you need to write here. So just here we created a node with the value then if head equals null, yes, absolutely creating it with respect to the current node, and else you are making it the last node. Let us execute this one. We made it. Yes, case 6 is also fine. Now we are trying to execute this one. You can see initially, let us suppose I'll directly give initially what is this display, linked list is empty. Let us suppose if I give 3, I'll give 6, insert at end. Actually there are no elements. If I give the value, it has to take successfully and it has to create the node, right? So let us see. Yes, you see the display. Yes, 20 is taken. Now I want to insert a node at beginning, maybe with 10 value. So you can see the output 10, 20. Now insert at the end, option 6, 30 might be. So 3 for display, you can see, yes, successfully. Again insert at end, might be 40 I'm giving. So you can see the display 10, 20, 30, 40. Might be one more node, option 6, which is might be 50 I'm giving. You see the display part. So here also you can see, you want to display in reverse, yes you can do, which is option 5. So 10, 20, 30, 40, 50 will become 50, 40, 30, 20, 10. Option 5 you can see, yes. So you can see the answer 50, 40, 30, 20, 10. So like this easily at any instance you can display in reverse also. So for this, how to insert at end we have seen. Now anyway, who are writing the program, they can check it out. I'm showing that now insert at end function. Yes, you can see. So this logic is very most important. Now we can go for our question, that is the next one, which is option 7. Insert at a particular position. I am erasing this. Yes. Yeah, insert at particular position. How to make it? We'll see option 7. Insert at a position. Yeah. So this is what very important. Anyway, I'll give it here. Insert at a position. Case 7. I'll take the help of this one. I'll copy it. Which is case 7. Enter a value, once the value. Now you can see, when you want to insert at a position, you need not only value and also position. Enter a value and position where you want to insert. So %d, %d. First give the value, then position, ampersand. Position can be given as POS. The variable POS has to be declared here. I'll declare, yes, POS is the position. And now the function I will write insert underscore position, where two parameters, value and position, POS. Now I want to define this function. I'll define this function, you can see. So void insert underscore position, where I'll take two values. One is int x given value, int p for position, like this. Anyway, the first point we need to remember is, what if the list is empty? Anyway, I'll take the help of this one. I'll simply take this one, where it has to create it. I'll copy this one. Initially the node will be created like this, and if it head equals null, means absolutely you can make it directly. You can insert it with that node, with the create function has to be executed. Now what if it is the position is equals to 1, if p is equals to 1, that means you are inserting your node at first position. Can I say it is insert node at beginning? Yes, absolutely. All right, if p equals 1, you have to execute insert underscore begin, which is you are inserting at the first position with respect to the value x. No need of position, give it as a parameter. Now of course, if head equals null, you can make it, else is fine, right? If not, only anyone to be executed, else. Now I am checking. Anyway, what is the last node? Anyway, you need to go for insert underscore end, but we cannot count exactly, right? But that's why we'll make it for the end node, how to make it. But before that, we'll try to write the logic here. Now let us suppose this is a node 1, this is node 2, this is node 3. I want to connect this node in between these two, like this the connections has to be established. Now what are the things has to be done? If it is, let us suppose this address is 200, means here it is 300. Why? Because initially this is connected, this is 200 initially before connecting. Now here it is 100, anyway we are not touching this. Now what changes we need to do? Here also we will make use of a temporary variable where you need to traverse like this one by one. Now when the temp is here, now you need to process the same. Like when the temp is here, this 300 should not be here, it should be 400. That means temp of next. What is temp of next? Here it should be NN, first thing. Now before that, what is NN of next? Here this has to be connected, right? NN of next should be this value, which is 300. What is 300? NN of next, here you need to have 300. How to write it? How do you know where is 300? Here it is initially. So first I'll write NN of next equals to, what is the temp of next? So means here 300, which is 300. Why? Because here it is 300. Now temp of next, then I want to update. Anyway, I'll make it other also. What is NN of previous? What is NN of previous should be this temp. So I'll write it as temp. Now this part also will be implemented. Now here also, what is this actually? NN of next. As of now, NN of next is 300. 300 to the previous is to be updated as NN. This is the one thing you can do. Or else, if you don't update NN of next, so if you don't update temp of next, before that also you can write what is temp of next? 300. 300 to the previous will become NN. So two ways you can write it. But anyway, before temp of next is NN. If you don't update this one, before that if you want to write, yes, you can write it. Temp of next is 300 to the previous, which is 200. I mean NN. Here you need to write. Or if you update temp of next is NN, means here also 300. There is no availability of 200. I mean 300 here. Here it is 400 now. So there is no availability of 300 here. So that's why NN of next. What is NN of next? 300. Now to the previous. So that is also you can write it. Both are possible. I'm writing here all these statements. First thing is, what is NN of next? What is NN of next is equals to temp of next. NN of next is equals to temp of next, which is the first thing you can go for it. And I'm not updating temp of next now. Temp of next, which is 300 as of now. To that, what is the previous now, which is equals to NN. This is a statement you need to understand. Now update temp of next. What is temp of next, which is now NN. That is also, that means temp of next to the previous is NN, temp of next is now NN. And one more thing, NN to the previous, what it should be? NN to the previous, which is should be temp, the current temp. Now this part, what is temp actually? Till now we didn't declare it. So we'll declare temp. Initially starts with head node, and here while loop has to go. I mean for loop, how many times you need to make it? For I starts with 1. Anyway, if it is 1 means, if position is 1 means you are not taking, that's why I less than, so it is I less than p minus 1, I plus plus, only one time it has to go. If it is third position, so we are inserting at the third position, right? So that means here you can see is a position 1, 2, 3. Third position means your temp first it is here. So if I write 1 less than or equals 3 minus 1, 1 less than 2, yes, fine. So temp equals to, so temp will go like this. Of course, first temp equals temp of next, not yet we have written. So that is the one thing we need to make it. Then only we have to temp equals to temp of next. This part has to be written first. Once it is done, that means temp one time. So temp will goes to the second position. Now stop there. Why? Because third position. Let us suppose fourth position. Your temp has to stop at third position. You can see what is p? Fourth position. 4 minus 1, 3. So I takes 1 and 2. Whenever it is 3 comes out. So this is what you can make it. I think it is absolutely fine what we have made it. Once again, nn of next means here I am writing what is nn of next equals temp. What is temp of next initially? 300. So 300 I am writing here. This is filled up. Temp of next to the previous. What is temp of next? 300 to the previous. This part is filling with nn. Yes, this nn value. This is filled up. Temp of next equals nn. Temp of next, what is that? 300. Now it should be updated to 400. Yes, this connection is established. Now anyway, nn of next, this connection is also established. Nn of previous equals temp. What is this value? Which is temp value. So 1, 2, 3, 4 changes has to be done. Now one more thing. What if you are inserting at the last position? Will it work out, and what you need to make it? You need to update the tail value also. That is also very most important. Now how can you say that is the last position you are inserting? That means if there are 4 elements, 4 nodes in the linked list, you want to insert a node at the 5th position. How can you know that? That is what here you can see. That means your temp goes like this. 5th position means your temp will stop at the last one, right? 4th position it will stop. Now you can check it out. If temp of next equals to null, if temp of next equals null, then you can say that yes, the inserting at the end function to be executed. So that is what I'll write here. If your temp of next is not equals to null, let me write like this, is not equals to null means it's not the last position. You have to do this one. So that's what we need to write clearly everything. If it is not the last position, you do all these things. Else means yes, it is a temp of next is null means yes, the position is a last position where you want to insert. Then insert underscore end function to be executed. That's it with respect to the value x. So this is what you can do clearly with respect to this one. Anyway, if it is the last position, I think only you have to do 2 things. Temp of next equals to nn and nn of previous equals to temp. That's it. And also tail value also to be updated. Anyway, in order to avoid that confusion, so if your temp of next is not equals to null means it's not the end last node, so you can make it. Else means it's end means you directly go to the insert underscore end function and make it. I think this is fine. I hope. Let us see with this respect to the output, and if any errors also we'll see. Yeah, the variable I to be declared. We'll see the execution whether we'll get it or not. And anyway, I'll start from option 7. Why? Because if it is no nodes in the linked list, even if I give, if I d equals to null, that also we have given. Even if I give option 1 also, if I give 20, it has to create compulsory, right? So you can see. But with 1 it is created. It's not with, of course, enter the value and position. Of course, I have given in reverse. Once again, I am giving. Yeah, we'll see the execution and output here. I'll start with option 7. Yeah, enter a value and position. Value is 20 and the position is, there are no elements, whatever it may be. If I give even 2, 3, 4, whatever position, it has to insert at the starting point. Let us see the display part. Yes, absolutely fine. Now again I want to insert 7 at position 1, option 7, where the value 10 at position 1 means what? Position 1 means 10, 20 it should be. Successfully, yes, you can see 10, 20. Now I want to insert at position 2. That means the value 30 I want to insert at position 2 means in between 10 and 20. So the answer should be 10, 30, 20. Let us see the display part. Yes, perfectly fine. Now I want to insert at the last, option 7, 4th position, right? Already 3 elements are there. I want to insert 40 at which position? 4th position. Let us see the display part. Yes, perfectly fine. So this is what you need to write the program without any errors. One more thing you can do, 7 and I'll give the value 50. I want to insert again at fourth position. Fourth means now it's not the last, it's in between 20 and 40. You can see the output. Yes, perfectly fine. So now, so I want to insert at first position now, something like 60 at first position. Will it be done? You can see the display 60 should be at the first. Yes, perfectly fine. So there are no errors. So I'll erase this one. So clearly check it out, insert underscore position, the code what I have written here. So here option 7 I have given and case 7 where two values to be given as input, value and position and parameters also. So we are done with insert at end and position. Next we will see this delete node at beginning, end and particular position. Thank you.